Hey guys, we're going to go over how to do quantitative energy problems, quantitative heat problems. So heat, we're going to call Q. We measure it in joules. We use that capital J for the unit. M is mass in grams, little g. Then we're going to heat capacity. Heat capacity is basically how much heat 1 gram of a substance can absorb is at 1 degree. So you see when there's a temperature change, delta, in a solid or liquid water, when the graph has a slope. We'll go over that again in a minute. Change T is the change in temperatures, temperature final minus the initial temperature, and it'll give you the change in the delta T. So I'm going to show you an example here. This is number 1 off of your worksheet. So we have a cup of coffee. They're going to give us the mass, 140 grams, and it cools from 75 to 20 degrees. How much energy is used? So we know we're on a curve because our temperature changes 5 to 20. So it will look like this, 75 to 20. We're going to Q1. This is cooling liquid water from 75 to 20. So to find the amount of joules that this thing lost, we're going to use this formula. Q, which is heat, equals mass times heat capacity times change in temperature. Right, so they give us our mass, 140. The heat capacity for liquid water is 4.18. This will be given to you each time. It's on the top of your worksheet. And then your change in T is final temperature minus initial temperature, which is 20 minus 75. It'll give you negative 55 degrees. We're going to plug all this into this equation. This gives us Q1 is going to be 40 grams times 4.18 times negative 55. If you multiply the 3, you get negative 32,186 joules. So this is how many joules the coffee lost. Right? Second example is going to be a phase change, number 2 on your worksheet. During volleyball practice, lost 150 grams of water from sweating. Basically, it evaporated off your skin. We're going to draw a heating chart, which is going to look like this. Flat line evaporation. This is Q1. So when we have a phase change, there's no change in temperature. And we're going to do something a little different from the last one. We're going to use H of V, the heat of vaporization, for water, not C. All right, this is our equation. Q1 equals mass times the heat of vaporization. So Q1 150 grams times 2,260. This again is given to you, this H of V. It's at the top of your worksheets. Multiply, you get 339,000 joules. So you have to draw these little charts, your heating and cooling graphs, and you have to choose the correct energy content for each one on your worksheet here. So some hints here. Use H of F for flat lines, melting or freezing. That will be temperature change. Use H of V, heat of vaporization, for flat lines. This is at 100 degrees. Let me put this at 0. This is 0 degrees, and this is at 100 degrees. All right. So if you flat lines, you're always using H of V of F. Now you have a slope, and you see a slope is always going to indicate heating ice or heating liquid water, or cooling ice or cooling liquid water. But if you have ice, you're always going to use 0.1 for your heat capacity, and if you got liquid water, 4.18 for your heat capacity. These will always have slope, means always a change in temperature when you see